For basically as long as we've been doing science, physicists have been on this epic quest for a theory of everything. One single beautiful explanation for the entire universe. But what if that quest has hit a wall? A fundamental, unbreakable limit that we can never ever get past. What if the universe is, by its very nature, just unknowable, in the way we've always dreamed?
Think about it like this. What if the universe's rulebook contains sentences that are true, but that we can never, ever prove? This isn't just some late-night philosophical question. This is something that gets right to the heart of physics, of logic, and of reality itself.
So this grand prize, the theory of everything, you can think of it as the universe's source code, a single, complete, and hopefully elegant set of rules that everything else, from gravity to you and me, just kind of emerges from.
And we've been getting closer and closer for centuries, right? Newton, he gave us this idea of a clockwork universe. Then Einstein comes along and completely warps our ideas of space and time with relativity. Then quantum mechanics shows up and reveals this bizarre, fuzzy, probabilistic world at the smallest scales. The final frontier, the big boss battle, is quantum gravity, the mission to finally stitch those two big theories together.
But here's the thing. The dream wasn't just for any theory. The real hope was for a theory that was, well, algorithmic. Basically, a finite set of rules and starting points that you could, in theory, pop into a powerful enough computer and have it spit out every single physical truth about our universe.
Let's just give this hypothetical superprogram a name. We'll call it FQG, for formal quantum gravity. In this perfect dream world, everything, space-time, particles, the whole shebang, would just emerge from running this foundational code. It's the ultimate it-from-bit idea. But there's a huge problem. And this problem, it doesn't come from a particle accelerator. It comes from pure, cold, hard logic.
And this is where the story takes a wild turn. The roadblock is what we might call the go-to wall. It's a discovery from way back in the 1930s that basically put a hard limit on what any system like our FQG could ever hope to do.
And this isn't just one little paradox, folks. It's a triple threat. The limit was first nailed down by the legendary logician Kurt Gödel, but his work was later backed up and expanded by Tarski and Chaitin. Together, their discoveries prove that any computational system that's powerful enough to be interesting, well, it's guaranteed to have blind spots.
Okay, so here's the absolute core of the problem. Gödel proved that in any powerful and consistent system, like math or our hoped-for theory of physics, there will always be statements that are 100% true, but that are impossible to prove from within that system. So you end up with this permanent, unbridgeable gap between what your theory can prove and what is actually true.
The implication for physics is just staggering. If our universe is based on a consistent set of rules, then it must contain physical truths that no algorithm, no supercomputer, can ever figure out on its own. The original quest for a simple computational theory of everything, it's hit a logical dead end. It is impossible.
But hold on, this isn't where the story ends, not by a long shot. In fact, this huge limitation doesn't really close a door. It actually throws one wide open to a much deeper and honestly, a much cooler vision of reality.
So what do? The researchers behind this idea propose what they call a meta-theory of everything, or MTOE. You start with that computable core, our FQG, but then you add a brand new, crucial ingredient, a non-algorithmic truth predicate. You can kind of think of this as an oracle, or a form of deep intuition that lets the theory see truths that are forever beyond the reach of just crunching numbers.
This totally reframes the whole goal. It's not that science is broken. It means our very definition of what counts as a scientific explanation has to get bigger. It suggests that some things in the universe are true for a reason, but that reason might not be something a machine can ever calculate.
And this is where things get really, really wild. This whole idea plugs directly into a famous argument from Lucas and Penrose, who suggested that this is exactly what human consciousness does. It can see or grasp truths that are beyond what any computer program can prove. Our own minds might be tapping into this deeper, non-algorithmic layer of reality.
So, this new way of thinking doesn't just reshape the future of physics, it also delivers a pretty stunning verdict on one of the biggest, most mind-bending questions of our time.
Come on, we've all thought about it, right? Is the ultimate sci-fi trope. Are we all just characters inside some giant cosmic computer game? Well, this theory might actually have a definitive answer.
The logic here is surprisingly clean and direct.
A computer simulation, by its very definition, has to be an algorithm. It's a program running on hardware. So at best, a simulation could only ever represent the computable part of our universe, the FGQ, but it could never contain those non-algorithmic, unprovable truths that the full meta-theory says must exist.
And that leads to a conclusion that is just inescapable. If this framework is right, our universe contains truths that simply cannot be computed. Therefore, our reality cannot be a computer program. The simulation hypothesis isn't just unlikely. According to this logic, it's flat out impossible.
And look, this isn't just some abstract mathematical idea. The paper points out that this kind of undecidability is already popping up all over real physics. We have problems where we can't write an algorithm to figure out the exact interior state of a black hole, or to predict for sure if certain materials have a spectral gap. These are real-world examples of that go-to-wall making its presence known.
All right, so let's pull all this together. Where does this leave us? What does it all mean for that grand scientific quest?
The most important thing to get is that hitting this wall is not a failure of science. It's actually one of science's most profound and amazing discoveries. It's not a barrier, it's a signpost pointing to something deeper.
What these limits really show us is that reality just transcends simple computation. The universe isn't just a big pile of data waiting to be processed. It has a kind of depth, a richness, and complexity that no purely algorithmic system could ever hope to fully capture.
To put it in the paper's own powerful words, the ultimate theory won't just be about information, about its from bits. It's going to require this deeper layer of non-algorithmic understanding to ever be truly complete and consistent.
And that leaves us with one final, totally awe-inspiring question. For decades, we've been leaning into this idea of the universe as a giant cosmic computer. But if it's not a simulation, if it isn't just a flow of information, then what is it?